Scenario. A person with a backpack is at rest on top of a flight of stairs. The person then moves down the stairs at a slow, constant speed and stops at the bottom. Which of the following accurately describes the change in the total mechanical energy of the Earth-person system? Question. What type of energy is decreasing? Answer. The gravitational energy is decreasing because the height decreases. As the person walks down the flight of stairs, the gravitational potential energy of the person Earth system is decreasing because he is getting lower on the stairs. Next question. Describe that change in the total mechanical energy of the Earth person system. Notice that there is no acceleration here. There's no net force because in the scenario it says at a slow constant speed. So the total mechanical energy is actually constant for the Earth person system. That leads us up to this next question. Is there work being done? If so, by who and on what? Remember, the definition of work in terms of the work energy principle is work is equal to the change in kinetic energy. Is there any object's kinetic energy that is changing here? Yes, the person is doing work on the backpack. How? By exerting a force on the backpack in the direction opposite to its displacement. Backpack was right here. The person went down. In other words, the person is actually moving the backpack down with a force. The act of walking down the stairs, the person is doing work on the backpack because the backpack is moving. Remember, the backpack was not part of the Earth person system. So the backpack was by itself. The backpack has a change in kinetic energy because it went from rest to moving. Then back to zero again because the person stopped. That change in kinetic energy, you would say that there is work on the backpack. That leads us up to our last question. Is the work done on that backpack positive or negative? What does that mean? Well, the work is actually positive because the total mechanical energy of the backpack is increasing. It is only increasing because the final kinetic energy minus the initial. We know that the initial here was 0. So this went to 0. And we could say at the bottom it was at some value. I'm just going to make up, let's say, 2 meters per second, or its energy, so probably joules, right? So 2 joules, okay? That increase of 2 joules came from the person doing work on it. There you go.